Hi, everybody. A very good morning to one and all present here. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. So today, in our lecture series, we are going to see about a case study. So as a part of the subject, we have been dealing with several cases in several factors of different units. So today we are going to see a case similar to our subject, what we have been seeing in power systems. And today what we are going to discuss is about a real-time implementation of some metering infrastructure in a very nearby city or very nearby state or your union territory nearby Tamil Nadu. Yes, as you all know, the name is over here. It's nothing but the pilot project taken up by the Electricity Board of Puducherry. So, what is it pilot project? So they have implemented the advanced meters or advanced metering infrastructure in their place in the town. So, with the help of the smart grid implementation of all the meters in each houses has been changed to this advanced meters where the role of smart grid plays the first step. So today in this video, we are going to discuss about the smart grid and advanced metering infrastructure. That is a pilot project which is carried out by the government of Puducherry in association with the NSTC, that is the National Board for Smart Grid, with the central government project. Okay, so today we are going to take that case study and we are going to discuss in detail. Let's get into the video. What is smart grid? As you all know, the grid, okay, we get the power in a way of a conventional approach, that is a top-down model or a single line flow where the generation starts following with several ups and downs, step up or step down transformers and substations. The transmission happens, the distribution happens at the load end, we reach the power. But smart grid is quite different from it. Let's see in this video also what is the role of a smart grid in this advanced metering infrastructure. Before that, what are all the challenges faced by today's grid in the context of this advanced metering infrastructure? Okay, so we have faced 4 different challenges in today's grid. One is peak demand. What is peak demand? Let's see one by one. Second one, power theft. Third one, less visibility in the grid. Fourth one, aging infrastructure. What is aging infrastructure? So the transmission lines on the transmission corridors, which has been laid several years back, is even now used today. It is not being changed regularly because of due to many reasons, like the much more reason is the cost and the human resource involved is less. So this makes the system, the infrastructure to become old. So that is one of the main problem. Less visibility to the grid. So what happens in the grid at the load center or at the sending end or at the receiving end to know immediately has been quite difficult. Third one, very important, is the power theft. So power theft at different points or different locations near the generating station, through the transmission lines, tapping of powers, and untouched metering, and changes in the meters, all those things considered as the power theft. And peak demand. So peak demand is one of the important concept. So what is this peak demand? So we already highlight, we use the daily load curve methods, daily duration core curves, weekly curves, monthly curves for load predicting the load, and even yearly loads. Okay, so in spite of that, there is a small difference always exists between what is the generation, what is the actual demand, and what is the projected demand. Okay, so all these three things should go in line with each other. So what are the 3 things? The supply and the demand. So there comes how you decide over the demand. So what is the generation? What is the actual demand? and what is the projected demand. All has to be in line with each other. That you can see in the image shown or the graph shown below. That is, it is the relation between the generation, which is marked as blue color lines, actual demand in red color line, and the projected demand in dotted lines. So see the correlation between the three in all the times. Okay, so the time is taken in the x-axis. So in all the times, day or night, it should have a match with each other. Okay, see in one place at the center, it's been the spike is high when compared to the projected demand. So in such cases, there becomes a problem. So what is this peak demand? So the tangent code, okay, discuss over the what is the need for the next day demand, and it blocks on 15 minutes. So markets, POSCO, we know that the Central Board of Markets, a generation schedule for various plants, EMS, NLDC, RLDC, and SLDCs. Just give what we have already requested for a generation and the line schedules for various plants, generation units. It receives to the tangent code, and we give distribution to the different consumers. Okay, so what is this model of smart grid? So instead of having a single way communication from the generation end to the customers, so it is now the interlinking between all these spaces. It's not from the generation to transmission, distribution, and the customer. It is the interlink between, you can see the different interlinkings. So this is a source file from NIST, from the national board. So that is the generation, transmission, distribution, and the customer. Here also comes the service provider, operations, and the market. So always there is a complete interlinking. So the customer can have a link between the generation and the markets and the service provider. So it is now it becomes a bi-directional flow. Even at the customer's end, you can see a solar plant or a wind where you can generate power and you can give it back to the power market. Okay, a service provider and an operator. Okay, so this is the main or the important part or the important concept of a smart grid while comparing to the conventional grid. Because the main point we can take it up is the only one line power flow is possible in the case of conventional grid, that is from the generation to the consumer end. But in the case of a smart grid, there is possibility of bidirectional power flow. That is a very important concept behind your smart grid. So now coming to our advanced metering infrastructure. So what is this advanced metering? So instead of having a traditional meters, we are going into a new type of meters, which is called as the smart meters. So what is smart? So what we have something smart in this. So you could see the different applications or the features that can be performed by this smart meters are listed over here. I'll just go by one ESI. Okay, energy service interface. That is HAL network interface components with NIC. NIC network interface component to exchange data to outside world. LOV detector, loss of voltage detector to send supply failure. TOU register, time of usage register, that is billing will be based on time of use of energy. So input output unit, connect or disconnect of circuit breaker, transformer, temperature information. Power quality, measures and stores the power quality data. Load profiles, measures and stores various load profiles such as the maximum demand, remote support, remote firmware upgrade, and the configuration. Security, detects and alerts meter tampered or tampering and power theft. So all these things are performed by a single meter. So what we saw as the challenge in the normal grid, the 4 different challenges in the first slide, is now taken care by this smart meter. So the smart meter network interface card has this following application. That is a distribution application apps like meter data management system, demand response management system, distribution management system, outage management system, and customer information system. So this is even done with a very simple concept of interfacing the network with the meters. Okay, so how they are interconnected, how the communication takes place. There's nothing but the telecommunication. We use a simple SIM, what we use in the mobile phones, in the meters. Okay, so the smart meter starts communicating with the different persons like the user, the customer, the utility, the operator, and everybody. It can easily communicate without any human interface. So here we see the block diagram for this telecommunication media, smart meter, GPRS, modem, and the distribution operation applications. Yes. Now coming into all these features, what we have discussed now, we are moving into the smart grid pilot power project taken by the government of Puducherry, the Electricity Department of Puducherry, and the National Power Grid Corporation. Okay, so they have completely implemented the smart grids, that is the advanced meters in even each small household till the biggest industries or the government or the commercial buildings, wherever the smart meters have been implemented. So here you could see some images which was taken from the NSTC website for the purpose of education purpose. So we can see in each house they have implemented a smart meter. So you can see the at the end, what is the infrastructure, and at the office side and at the operation side, smart grid control center PEDs available at different parts of the Puducherry project. So what is the screenshots tell about? So what are the attributes implemented is the advanced metering infrastructures. It can perform the peak load management, including demand side management and demand response, outage management system, renewable energy integration with net metering, power quality management, microgrid, energy storage, and electric vehicle with solar charging station, street light automation. So all these things can be managed with the help of these simple smart meters already implemented. So what is the use of this smart meters? So you can see how this takes place in the Puducherry project. Okay, so this you can see in a specific area called Marapallam substation. From there, we are going to take two lines, which has several feeders for towns and different areas. Okay, we have the DCUs, DSUs, advanced metering infrastructure, that is smart meters for each houses, controlled by SCADA by collaborators, OMS, GIS mapping, PLM, MDMS, and head-end. So the Brilliance, the Puducherry Control Center also has a link over it to data collection unit, transfer monitoring unit, and all those units have interconnection between all the places. So the communication becomes easily from the even at the load side. So this is the location of installation of these smart meters in the Puducherry. So you can see the image taken from the Google. So where all these smart meters are implemented, all those green colors shows you the smart meters. Blue color represents the APFC, and those boxes, green boxes represents the DCUs, and yellow color lines represent the DPs. So this is the outage management system, one of the important application of the smart meter. So you will receive a message. So Marapallam, so the outage happens. So what time, what period, and that has been received to the customer. So this is the screenshot of the customer who had received the message. Okay. Yes, so we saw about the power theft. This is the main receipt by to the utility, to the as a power source from the power grid, where there is a tampering happening in some part of the area. So they have given the meter, date, time, and area of Puducherry where it has been happening, and all those things, so that the utility can take these action immediately. So based on all these things, what are all the outcomes? What are all the applications of this advanced metering infrastructure? Is the bulk meter reading, home energy management system, outage notification, connect or disconnect the system, asset management, remote programming of smart meters. So I think you have come across a brief case study about the implementation of a direct implementation of a real-time project of Puducherry pilot project. Let's see in the next class. Thank you.